Good morning to all of you. In the last class, we had learned about how the discovery of spin was made. So, we have also seen that initially it was the orbital motion that was considered as a source of angular momentum, right? That's what you get from Schrodinger equation when you consider the wave functions, the angular wave function, the radial wave function. That gives you the angular momentum due to uh, what we say. Oops. uh, so angular momentum due to the uh, movement of electron around the nucleus, just like in this path that is shown by the circles drawn in and the arrows indicated moving. So that's how you, इस तरह से आपको पता चला कि इसमें ऑर्बिटल एंगुलर मोमेंटम होता है और ऑर्बिटल एंगुलर मोमेंटम का डायरेक्शन क्या होगा, how it is the momentum will be oriented in three-dimensional space, that is also quantized, and that was what we knew as we learned that as space quantization. That's the term that we use, space quantization, right? Now there was an effort made to verify or confirm whether this thing actually exists, what has been theoretically predicted, and does it exist as per the theory. अगर exist करता भी है तो क्या वो सारे जो whatever has been proposed as per the theory, क्या उसी format में उसी तरह से सब कुछ exist करता है. So all these things were done, and results that was found, जो मैंने आपको बताया, results were something very different. ये तो कंफर्म हो गया जो एक्सपेरिमेंट उन्होंने किया, द एक्सपेरिमेंट दैट दे कैरिड आउट, स्टर्न एंड गर्लैक, where they considered that it's silver atoms, heated it in an oven. So this is the oven, and then it passed through the magnet. So you have magnet poles, and then they expected, because they have been heated, there will be random orientations of angular momentum. That's what the likely thing is. So they are trying to randomize. So if there is uh, so and it is the component of angular momentum that contributes to the z component of, so z component here is the, z is the direction of the magnetic field here, right? So magnetic field की direction में जो angular momentum का component आएगा, ठीक है, that is a z component, only that will contribute to magnetic moment. So that will feel the that will behave as a tiny magnet. The electrons will behave as tiny magnet, and according to their z component they will appear, they will feel different force, and so they might appear on the photographic plate from like spreading over the entire thing. If there is no quantization, they will hit all over the place. Okay, and if there is quantization, then they should hit at certain distinct places on the photographic plate only, not all over the place. Okay, so this was the classically expected outcome here, and this is the observed outcome. And this was what we learned, that yes, there is space quantization because this is the actual thing that happened, right? So orbital angular momentum of electron is the momentum, angular momentum of electron is quantized. But when they try to find out that how come you always learn from quantum mechanics, from the analysis of Schrodinger equation, that number of orientations here 1, 2, right? Here 2, and that what we have learned, it is all given by 2l plus 1. What was predicted in the theory, l will be like 0, 1, 2, and so on. None of this, it cannot give, none of this gives you 2. So you cannot, so it So if L is 0, 1, 2 and so on, if it can have only integer values, then how come there are only two possible values? So two different orientations. So there was something, amiss. There was something which were missing out. So then they also realized that silver that they have taken, it is the silver atoms, what it is for krypton, then it was like, sorry, where is this? So silver, when you talk about silver, it has this thing, krypton 4d10 for 5s. So what does this mean? The angular momentum is so when you have closed shell, this is represents a closed shell, angular momentum will be 0. uh, so 0, because all the direction ultimately it will cancel out. It is a vector, so the different so you have plus 1 minus 1 different directions, so all together taken that will turn out to be 0. And in addition to that, the 5s1 s orbital for s, L is 0, so again 0 momentum. Then what is this? So this silver atom that they had taken in the experiment, it had 0 orbital angular momentum, but this they are getting this electrons at atoms are hitting, and they are moving and hitting at two different spots under the influence of magnetic field. तो ये जो था, इस चीज को प्रूव करता है कि मतलब स्पेस क्वांटाइजेशन है, बट द सोर्स ऑफ एंगुलर मोमेंटम इज समथिंग एल्स. व्हाट इज दैट? So it was proposed that in addition to orbital angular momentum, there can be another source, that is movement of uh, like Earth spinning on its own axis, the day and night that happens. So if we consider electron to be moving around its own axis, and that particular thing was called spin, right? That was what we call as spin, and this came out to be so that's what we, so the source of angular momentum, not the orbital angular momentum, it is motion about its own axis, and that was called spin. And then it was researched that L, instead of L, it should be called, we should give another specific quantum number. It's entirely different thing, right? So it will be governed by different set of quantum numbers. And this, later on it was found that ये जो angular momentum है, it is intrinsic to the electron. It will always be there with this. Just like mass is inherent property, just like charge is an inherent property of electron, wherever it will be bound electron, unbound electron, free electron, whatever, mass charge will always be there. Just like that, this intrinsic angular momentum due to the spin will always be there. And this emerged later on to be a very, very fundamental property of any subatomic particle. All particles are fundamental particles: electron, proton, neutron, photon, light का particle. Such the light that is when visualized as particle, that also has spin. So that was realized later on. So the discovery of spin was, watershed moment, you can say. It is changed the way we thought about uh, so many things. So, uh, so that's how we now learn that this is the angular momentum, and this is the z component. You can calculate it, and because there's uncertainty relation in the, so just like the Heisenberg uncertainty principle was a special case of general principle of uncertainty, right? It was which relates to the uncertainty of momentum and position, right? In a similar way, there is also uncertainty relationship between the three components of uh, angular momentum, Lx, Ly, Lz, which was discussed in previous slide. So this uncertainty things was like Lx, Ly, Lz, they also follow uncertainty. मतलब अगर एक को specify कर दिया तो बाकी दो we are totally uncertain about the other two components. Now here what happens, that Z is specified, Lz specific quantum number जो आपका है ml, and in a similar way here the if it is spin it is the ms, the Z component of angular momentum. If that is specified, then other two components cannot be specified. And when you are drawing arrows like this, if you draw arrow like this, there is problem with this picture. What is the problem? When you are drawing this arrow, you are fixing Z and you are also fixing the x and y component, right? So you have projection of this component lies in this xy plane, तो वो भी fix हो जाता है. So somehow drawing pictures like this to show the direction of angular momentum is not entirely correct. It violates the uncertainty principle, and so it was suggested that we should draw pictures like this. If you take, so as long as, so if you are making this particular angle theta, move these arrows around this z-axis, it generates a cone. This purple cone that you see is generated by this. Or in other words, I should say, like, if you place this vector anywhere on this cone, the z components remain same, and at the same time we do not know about the x and y component, right? So x and y component can be anything, we are not uncertain. So but z component is fixed as long as this vector is placed on this particular cone. Similarly, if it is placed on this cone, green one, then there is certain different, the z component is mlh cross. So to account for that uncertainty principle amongst the different components of Lx, Ly, Lz, that angular momentum, it was suggested, it was that we should always draw pictures like this to indicate uh, indicate the orientation of angular momentum, and also to account for the uncertainty. So the z component gets fixed, we are totally certain about z, so we are in the same way, that also means that we are totally uncertain about x and y component. So that's how we draw it. Now in the same thing applies to spin. So when you are drawing trying to show, so same thing applies to spin. So spin, as suggested, for a given particle, there can be only, when we are talking about electron, the angular momentum due to spin is given by s is equal to half. This is invariable, ये change नहीं हो सकता. एक particle के लिए एक तरह का ही होगा. For electron, proton and neutron, for all this s is equal to half, right? Or the magnitude is equal to what? Under root s into s plus 1 h cross, right? So that you can calculate very easily. आप इसको substitute कर दीजिए values, half plus 1 into half, so 1.5 into 0.5, so something like that. And take the under root, so it will come out to be 0.08 0.86, something like that. Okay, h cross. So ये वाला थिंग हो गया, ये चीज होगी. So if it is half, so you can have only plus half ms or minus half. And so as long as I place this vector on this cone, anywhere on the cone, it has same z component. So z component is same ms h cross, that is the z component. So we are also showing the orientation in 3 dimensions. We are also displaying the uncertainty principle through our pictures. So that's important. Whenever you draw angular momentum, direction of angular momentum, always show this cone. Now you are master students. अब आप बच्चों की तरह वो वाला ड्राइंग नहीं कीजिएगा, अप एंड डाउन एरो, ठीक है, वो सिर्फ जेड कंपोनेंट था। अब आप ये भी जान रहे हैं कि अच्छा ये जो एंगुलर मोमेंटम वेक्टर है स्पिन वाला, वो एक्चुअली ऐसे जाएगा, है ना, कोन पे रहेगा। ये जो अप एंड डाउन ऊपर नीचे दिखाते हैं प्लस और माइनस, वो तो उसका जेड कंपोनेंट था सिर्फ, राइट। So now this is thing to realize. And the angle, the fixed angle that is makes it 55 degrees, you can easily calculate if you know this thing. We can always calculate how much is this. We know both the things, so apply Pythagoras theorem, you can get to know what the angle could be. Okay, so that's something. So that was the summary of this thing, orbital. So there are two sources of angular momentum. So we are talking about the angular momentum of electron. So contribution to angular momentum comes from two things, orbital motion and the spin. So orbital angular motion, this is how it varies, and this is how you get the magnitude. The direction, the orientation of the angular momentum in three-dimensional space is given by this L2 minus L, so ml values component, so ml h cross, right? And then you also have the another source of angular momentum for electron, that is spin. So that has a quantum number half fixed. ये वेरिएबल नहीं, यहाँ पे 0 1 2 so on, but here it is only half. So किसी भी पार्टिकल के लिए जो उसका इनहेरेंट प्रॉपर्टी, जैसे मास फिक्स्ड होता है, चार्ज फिक्स्ड होता है, वैसे ही स्पिन भी फिक्स होता है। समथिंग विच इज इनहेरेंट प्रॉपर्टी, इंट्रिंसिक प्रॉपर्टी, दैट इज फिक्स्ड, इट्स इनवेरिएबल, राइट, it's constant. So spin, the orbital angular so orbital angular momentum is variable, it can change with a change in L. Spin angular momentum, it has same magnitude, it will never change. For an electron it will remain same, for proton it will remain same. Okay, so that's given by again multiplying S, वही formula है, just you are replacing L with S, that's it, and the H multiplying with H cross, component along Z-axis, MSH cross. So that's what you were showing by plus half minus half. When you are drawing this up down arrow, you were actually showing the Z component only. When you are writing electrons, समझे, जो अब आप तो दिखाते थे ये सब, ये अलग था, और right. And later on we will also go to multi-electronic system, then we will find that the two angular momentum vectors can interact, and we can get the summed up to L plus S. So vector sum will give you multiples number of angular momenta. Momenta is plural of momentum. So whenever I say, you should be able to pick up. Momenta बोलेंगे तो कई सारे, momentum बोलेंगे तो एक, just one, right? That's how we should. So we'll talk about this later. That's how you should understand this. Angular momentum is so important to understanding of electron. In addition to that, the spin, particular spin ऐसी चीज है जो हमेशा उस पार्टिकल के साथ रहेगी। इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन हमेशा उसके साथ रहेगी। ऑर्बिटल मोशन रहेगा जब तक वो एटम का हिस्सा है। एटम से बाहर निकल गया, if there is infinite separation between electron and proton, there will be no orbital motion, but there will be spin. spin हमेशा रहेगा, intrinsic property है, ठीक है। That's how we should understand. So that's what we were discussing last time also, that it's a very elementary thing. All elementary particles have spin characteristics of. So when we are talking about electron, proton and neutrons, they have this 0.86. So now you know what the angular momentum is. It is from your knowledge of, angular momentum is also called moment of momentum. This a famous thing that I always tell my students. This is a special thing, moment of momentum. Why we call it? Usually when we refer to momentum, we are talking about linear momentum, a particle moving on a straight line like path. So that we are talking about, so that is r into p, p into r. So moment of momentum. So that's why we call it, this is your linear momentum. So कल भी मैं आपको क्लास में बता रहा था ना कि जब आप भी आप मोमेंट सुनेंगे, मोमेंट इज समथिंग दैट इज takes into account multiplication of the factor r. So moment of momentum is, so when you have, if you know the linear momentum, multiply with r, you get the angular momentum. So moment of momentum is angular momentum. So that means r into mv, right? So you can easily equate this now, 0.866 h cross. So in other words, you can expect, so what we have now learned, mvr, the angular momentum, is 0.866 h cross. So m for electron is different, m for proton, neutron is different, right? This is, oops, sorry, so this is 1800. So if this mass is mass of electron is, let's say we write it as m mass of electron, so this will be like 1800 mp. Mass of proton is like something like 1800 times mass of electron. So what does this tell you? If you visualize electron, proton and neutron to be something like a small, very very tiny sphere, एक छोटा सा बॉल की तरह विजुअलाइज कर रहे हो, just like a small sphere spinning about its own axis, then you can easily substitute these things and you will realize that a proton will be essentially, electron will be moving much faster. So that means velocity, when you calculate v can be then calculated as 0.866 h cross by m into r, m by r. So if you see, nobody knows how small, if you are trying to see electron as a particle, you don't know what is the radius, how small it is. Picometer, 1 picometer, 1 femtometer, 1 attometer, what is the radius we should take? Electron is actually structureless, we don't know. Spherical. So let's take, assume the smallest size that we can measure as of now with the advancement in technology. What we can measure is 1 femtometer, 1 attometer, 10 to power minus 18. तो वो रेडियस लेके एक स्फीयर कंसीडर कीजिए, you try to calculate. So v, as mass increases, we will so proton, so that means a proton so that's how proton moves slowly when you are about its own axis. Electron moves much faster about its own fast spin, right? So far as spin is concerned, it must be moving very very fast. If they are visualized as spheres moving about its own axis, that's just like जो हमारा preliminary idea, सबसे पहले हम उसको, we start thinking about a spinning top. लट्टू देखा है ना, spin करता है, Beyblades, you call it, बचपन में खेलते हैं बच्चे. So just like that, spinning about its own axis. आप बेब्लेड से खेले होंगे, आपने वो सब लट्टू से खेला होगा. So you must just visualize those things. So that is the very very preliminary thing that we can think, what is spin when we try to think of. But electron will be spinning much faster, proton will be, because both of them having same spin angular momentum. So if they both, all of them are visualized as solid, as spheres, then will be difference. Electron will be moving much faster, and something very drastic, unusual thing happens. if you really calculate this thing, you will find that electron speed turns out to be much much faster than speed of light, and there must be something wrong with then suddenly मतलब आप जब कैलकुलेट करते हैं एक्चुअली कि कितना फास्ट होगा, so when you try actually measuring those things, you will realize that electron का speed तो light से भी ज़्यादा आ रहा है, which violates the theory of relativity of by Einstein's theory of relativity. So क्या कुछ गड़बड़ है इसमें? There must be something wrong. तो वही मैं आप स्पिन के कॉन्सेप्ट पे आपको ले जा रहा था. दिस द कॉन्सेप्ट ऑफ स्पिन इज वेरी इंपॉर्टेंट. एज आई टोल्ड यू, इट टेक्स यू टू द classification scheme in the particle physics, where you have this classification of fermions. So when S is equal to half integral, so half integral, or here the S is integer. So what we are concerned with, हमारे काम के लिए जो जरूरत है photon, here S is equal to 1, and what we are concerned here with electron, where S is equal to 1, sorry 1 by 2, half, right? So this is the fermions, and bosons are important. It is, so you know the scientist who has been named, this is bosons is named after whom? Satyendranath Bose. You must know that. So that was his contribution of this great man, the fermions, Fermi, after named after Enrico Fermi, and Satyendranath Bose. He, together with Einstein, he gave his theory, which was, and so this is the immense contribution. You start thinking entire particle system in terms of fermions and bosons. ओके, सो दैट्स बेस्ड ऑन स्पिन. और इसी से फिर आपका स्पेक्ट्रोस्कोपी जब आप समझने की कोशिश करते, व्हेन यू स्टार्ट लर्निंग अबाउट स्पेक्ट्रोस्कोपी, दीज थिंग्स आर वेरी वेरी इंपॉर्टेंट. द स्पिन ऑफ photon, the spin of electron is really when you try to conserve the angular momentum, these things will come into picture during the spectroscopic transition. We'll see about that. But going back to what I was talking about, spin, right? Spin, 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 spin. So we tend to visualize things like something like this, that these are the spinning. We try to think of spinning, moving about nucleus, electrons or protons, everything moving about its own axis. We try to often represented by tiny spinning balls, which may not be entirely correct. Why? Because when you देखिए, शुरुआत के लिए ठीक है, when you are initially as a beginner, when you start learning in class 11 about spin of electron, that's fine. You visualize this like a spinning top. But when you now you are grown ups, right? You know, you can mentally you can think of you can analyze in a better way now. You have so when you realize this thing, now you can calculate the angular momentum. The proton, neutron and electron all have same angular momentum. Electron must be spinning fast. How fast? When you realize, you calculate it, something is wrong. So there must be something wrong the way we have been visualizing spin. Okay, why? Let me tell you. So it may not be actually rotating about its own axis, क्योंकि लाइट से फास्ट कुछ भी नहीं हो सकता. Nothing can move faster than light. So the linear velocity that you calculate, when you know this thing, you calculate, when you apply this concept mvr, the angular momentum is equal to under root s plus 1. So at any point of time, what is the v, linear velocity component that you can calculate, and that cannot be. So v is given by, so this is your linear velocity. Linear velocity will be under root s plus 1. So linear velocity turns out to be greater than light for electron. तो अगर इलेक्ट्रॉन के लिए हम कह रहे हैं कि उस तरह से नहीं हो सकता, जो हमारा कन्वेंशनल विजुअलाइजेशन है, like a spinning top, then there must be something wrong. It is an intrinsic property, all right, but we cannot visualize this as a spinning ball, because the velocity turns out to be how it turns out to be. Let me tell you something very interesting. So you know, sorry. So क्या गड़बड़ है? Sorry. So if the radius becomes smaller, the rotation will become faster. So for this moment, if you keep the momentum same and reduce the radius, velocity will increase, right? So if we say that particle electron nature of particle is fixed, and suppose we are confused about how small it is, femtometer में 10 to power minus 15 meter, 10 to power minus 18, we're not sure, we have not seen, we can't see electron like that. So let's assume the smallest thing, few attometer, 10 to power minus 18. Let's assume that it is either 10 to power minus. So if you reduce the radius, if r becomes smaller, the velocity v increases, right? It becomes, it is moving much faster. So the electron has a very very small size, and when you calculate this angular momentum, it is the tangential velocity, the linear velocity at any point is very much larger. Rotation becomes faster. So this you must realize when this you see this darker shade of r is to realize that this is when it is large to small. So from a larger value of r to a smaller value of r, radius decreases, the velocity which was small now becomes large, very very large. So see, this picture has been drawn very carefully, the things are written like this. So this is what happens. So if you keep the angular momentum same, which is true for a given particle, electron will always have same angular momentum. A free electron will have, just as its mass is fixed, its thing is fixed. Now if you just think over how small, how big it is, then you realize that if you consider the smallest measurable thing today, length that you can measure is few attometer. Maybe we can measure femtometer से भी थोड़ा सा कम हम लोग कर सकते हैं. So that's then you are talking about a very very large velocity, linear velocity, and no particle can move faster than light. So it is all, when you talk about electron, it is so electron spinning speed, when you calculate, you आप substitute करके देख लो, you do an exercise, you put this, equate it to 0.866, that thing, and then substitute its mass of electron is 9.1 into 10 to the power minus 31 kg. Take r, 10 to the power minus 18 meter. So take these values and try to calculate this thing. Your velocity will turn out to be about 100 times faster. You'll find that it is turning out, when you actually do calculations, you find that electron spinning speed turns out to be 100 times faster than light. So in ordinary textbooks you will see spin as spinning. So this will, in ordinary textbook, this is a problem. Like you never know about, you will never realize this unless you do your own homework. Start thinking about it. Calculate this thing. Okay, so what is the size of electron? How small it could be? Nobody has seen it. Electron is featureless. It has, you can't really see the length, diameter, anything like this. So it is a very different kind of property, and well, uh, well, So just like mass is an inherent property, it is something, a property which contributes to some magnetic moment. It is the origin of magnetic moment. So that's how we visualize it. And well, I can discuss more about this in my next class. So first thing is that we now realize that electron spin cannot be like spinning top. It is so quantum mechanical visualization, quantum mechanical treatment of spin is entirely different in as compared to what we have been visualizing it in classical mechanics. ठीक है, तो वो एक चीज है जो आपको ध्यान रखना है. एंड डू नॉट बिलीव एवरीथिंग. जब आपको फीड किया जाता है कुछ भी, आप कुछ भी कुछ भी बस विश्वास नहीं कर लेना है. अब तक जो आप सुनते आए थे, जरा सोचो, जरा समझो. it how it can become greater than c. It's not possible, right? So almost like, speed becomes very much 100 times faster than light. Superluminal का मतलब faster than light. Superluminal terms means faster than light. Something becomes faster than light, we call it superluminal. So that's a thing which we realize that it's not spinning top. We can't visualize it as a sphere like something moving with radius r at the, so at the equator you calculate the velocity, linear velocity at a point like this. So that's the first visualization as a mature master student. Okay, it's a pretty simple class 11 thing. Early days when you are looking at spin, it's okay to think like a spinning top, not anymore. ठीक है? So we'll talk about more in my next class. So thank you. We'll continue with this.